If you want to know everything about difference of two square and the application of difference of two square with regard to factorization of quadratic expression, then I want you to stick to the end of this video, because in this video I'll be treating that in detail. Hi, AC Okocha is my name, and this is just academic mathematics, where we make you a mathematics genius. This class is a sequel to our series. We have been in quadratic equation. This is a series in quadratic equation, and this is a continuation in our quadratic series. So if you have not seen the previous videos, I will encourage you to try and watch the previous videos so that you will understand fully what I'm teaching here. Now let's go straight to business. Factorization of quadratic expression with more than one variable, and we are concentrating on difference of two square, but I will give one or two examples that has to do with a variable. Generally, when we talk about difference of two square, a difference of two square is a quadratic expression with two terms, also known as binomial. A binomial in which the coefficient of both terms, that is the both variables, are perfect square and one of the term is negative. So what is the idea of difference of two square? Difference of two square is talking about the combination of two perfect square so that one of them is negative. You need to know what perfect square is all about. Perfect square numbers, you know the origin of perfect square numbers. Perfect square numbers are like what? How do we get perfect square numbers? I've taught you that before. That for instance, 1 square is equals to what? Is equals to 1. 2 square will give you what? 4. 3 square will give you what? 9. 4 square is what? 16. 5 square is what? 25, and so on. So these numbers down here is what we call perfect square. Now when you have the combination of these two numbers as a coefficient to a variable such that the variable is also squared, and one is negative, it is referred to as difference of two square. This is what I'm saying. For instance, I have that a square minus b square. Why is this difference of two square? Is difference of two square not just because both of them have square, but because the coefficient of both is a perfect square. Coefficient of a square here is 1. Coefficient of a square here is 1. So both of them have a perfect square, then this is square. So this now means a minus b times a plus b. When you expand this bracket, this is what you will get. So difference of two square teaches you to go straight to apply it without you needing to expand the bracket. If you expand this bracket now, you get a times a square, a times b plus ab, minus b times a minus ab, minus b times b minus b square. So this will give you a square minus b square. Can you see that now? So when you have something like this, when the bracket is the same, one is negative, one is positive, know that it will give birth to difference of two square. You can factorize this to this. You can also factorize this to this, depending on what you want. It's vice versa. For instance, if I have something like 2x minus y times 2x plus y, of course, this is difference of two square. I can present it in this form by just squaring this one. That is 4x square minus y square. That is the meaning. So you don't really need to open the bracket again. Just this square, 2x square, which is 4x square, that minus y square, which is the same way. If you have it like this, you can present here. So if I have 16 minus z square, what is it in this bracket form? This will give me what? 4 minus z times 4 plus z. So you just have to know it. That is what we call difference of two square. The expansion of this will give you this. This time this will give you the 16. So if you expand this now, you get this. So when you see something like this, where the bracket is the same, one is negative, one is positive, you don't need to expand. Just know that it's difference of two square. Okay, let's swing to action. We have a lot to talk about here. Now look at our first example. Example 1 says factorize each of the following. Factorize each of the following. Now let's start from the first one. The first one here is 1 minus 16p squared. If you look at this, notice that this one is a perfect square, this 16 is a perfect square. So we can actually expand this as what? As 1 minus square root of 16 is 4. Square root of p squared is p. Then 1 plus 4p. The expansion of this will give you this. So this is the application now. You just go straight to this. The same thing we can simplify or factorize the second one, which says that 9y squared minus 36x squared p squared. The same thing. What is this? The square root of 9y squared is 3y. Then the other side, square root of 36x squared p squared is 6sp. So you double the same bracket using what now? Using plus. And anyone can come first. It can be plus then minus. It doesn't necessarily need to be minus first. But the most important thing is that the bracket must be the same. One is negative, one is positive. Take note also, if here is plus, it's not applicable to plus. It's only applicable when the two are perfect square and one of them is negative, not both of them positive or both of them negative. One of them has to be negative. One positive, one negative. Then you can expand it in this form. Let's see the I, which says that 18s squared minus 8p squared. Now I like this one for a reason. If you look at this one carefully, notice that 18 is not a perfect square. Neither is 8 a perfect square. So what do you do in this case? In this case, you factor what is common. What is common between 8 and 18 is 2. If 2 is outside, what will remain? It will remain 9x squared minus 4p squared. Now, if you look at this bracket carefully now, you will notice that this is a perfect square. This is a perfect square. These both variables have square. So we can split this bracket now as difference of two square. This is what I mean. That is 2 bracket 3x minus 2p times 3x plus 2p. So we've succeeded in splitting it into difference of two square. I am moving very fast. You can always watch the video over and over again to understand. Look at example 2. Look at example 2. Interesting. This is a champ question. In 2008, number 14, they say we are to factorize completely. Now, you must have eye for the difference of two square, which I said, just see everything in this bracket like x or like p. See everything in this one like q. So you can now be able to apply because this is square, this is square. I get what I'm saying? I don't need to be replacing it, but yeah, you just have to see it. But for the course of this, just for this class, let me show. Just assume that everything inside here, see it like p. It's just like when you have something like this. Let me show you. It's just like when you have something like p squared minus q squared. So this p represents this bracket. This q represents this bracket. If you split it, you get p minus q, then p plus q. So that is exactly what we'll be doing with this. So this one you are seeing now, which is 4x plus 3y squared minus 3x minus 2y squared. If you see this bracket, the two brackets as one entity, which it is, and apply difference of two squared direct, we can say that 4x plus 3 minus 3s minus 2 minus 2y minus 2y. That is the first bracket. Then bracket 4s plus 3 plus 3x minus 2y. Maybe I put all of them in brackets so that you will not get confused. Are you seeing it now? So this is the splitting in difference of two square. That is this minus this in bracket, this plus this. Just the splitting of this. Can you see? It's the same thing. This side now is here. You are seeing here. So this will give me 4x plus 3y. If you open this bracket, you have minus 3x. Minus times minus will give me plus 2y. Then here will give me 4x plus 3y. You open this one, I have plus 3s minus 2y. So finally, what do we have? 4s minus 3y is what? X. 3s plus 2y, 3y plus 2y is what? 5y. Then 4s plus 3s, 7s. 3y minus 2y is plus y. So this is the answer. And that is option A. That is option A. That is option A. So you just go ahead and split it like that. Now, let's move on. Look at example 3. Look at example 3. Remember, you can settle down and watch it over, make your notes, understand it properly. And make sure you see the next video, the next class. I'm still in factorization of quadratic. The next class is where you see factorization of higher degree, greater than 2, degrees that are greater than 2, raised to the power of 3, raised to the power of 4, raised to the power of 5, raised to the power of 6, how to factorize, even raised to the power of 7 and 8. You will see all that in the next class. So don't miss that class. Now here, solution. Let's go. Solution. We want to factorize this. If you look at this now, almost all of them have square, but that is not even the issue. Since they are 1, 2, 3, 4, we can think of grouping and see if that will work. If we group this and this and this and this, can that work? But there is nothing common here. Here is a square s, here is minus b square y. This and this has nothing in common. But this one and this one has something in common, and this has something in common. Or we can say this and this has something in common, and this has something in common. So whichever one you want to pick. So I can as well rearrange this by calling it a square x followed by what? Minus b square x. Now notice that a is coming before b. So don't start with this b. If you start with this b, the arrangement will you have issue having the same bracket. Since a is starting, start with this one now. So you have plus a square y, then minus b square y. Then you can now factorize in pairs. In this first pair, what is common? S is out. What will remain? A square minus b square. In the second one, what is common? Y is out. What will remain? A square minus what? B square. Of course, you can see now, if you factor out what is common, out, bring it out, a square minus b square, what will remain here? It will remain s here. What will remain here? It will remain y. So this time, that is, you bring out what is common, it remains this and this. So in other words, we are saying that a plus y, s plus y, bracket, this is difference of two square. You must have I for difference of two square. Once you see something like this, just know it's difference of two square. So if we use this right of two square to split this, we have a minus b times what? A plus b. And that is option D. Option D. I believe that makes sense, is it not? Okay. That brings us to example 4. Example 4. Now look at this example 4. So if you look at this one carefully, you just have to look for a way to match them up, because this is 1, 2, 3, 4. If we say let's group, okay, this and this, s can come out here. It will remain 4y minus s. This and this, nothing is common. Okay, if you pick this and this, okay, I think that one will also work. If we pick this and this, 4y is out, and a 4y is out, we're left with s and y. Then this and this. I don't know. There is always more than one way anyway. There is always more than one way. So I have something else in mind. I don't know if this one I just thought of will work. But let's check. Let's check it. If it's not working, then I'll go back and use what I have in mind anyway. So let's use this and this. That is 4xy minus 4y squared. Then minus x squared plus z squared. Now, look at something here. 4xy minus 4y squared. Here, bring out this minus outside. What will remain here is s squared minus z squared beta. So here, what is common? 4y is outside, remaining what? Remaining x minus y. Can you see that? Here, this one means difference of 2 square. Oh, that will not work. This is x minus z, and this is s plus z. And this has nothing in common. So this will not work. Except you want to leave it like that, which is not really correct. That is why I said you need to watch carefully. Do your analysis before you start. But it's part of the learning process anyway. Now look at what I want to do now. This xy, I can merge this sy, s square and y square. I can factorize this. But let me start with this first. If I start with this, so that you will see what is about to happen, because if I start with this one, the minus will cause a problem. So let me start with this. This is z square. Then I'm starting with minus x square plus 4xy minus 4y square. Follow me carefully. So I have z square. I'll put minus outside. What will remain inside? S square minus 4xy plus 4y square. So I have the obligation now to factorize this bracket. I want to factorize this bracket. So here is z square minus, to factorize this bracket, two numbers you add to give you minus 4 times to give you 4, minus 2 minus 2. So this is s square minus 2xy minus 2xy plus 4y square. Follow me carefully. So I have z square minus, what is common here? X. It will remain what? It will remain s minus 2y. What is common here? It is minus 2y. It will remain what? X minus 2y. Can you see that now? In other words, we are saying that z square minus, what is common? Factorize the common bracket out. You have s minus 2y. If you bring it out, what will remain? It will remain here, x, and here, minus 2y. So notice that this and this is the same. That is perfect square. That means z square minus x minus 2y square. So this one now, you see this one as difference of 2 square. This square, this square, this is negative. So if you apply difference of 2 square here directly, you have z minus x minus 2y times z plus s minus 2y. Open the bracket. You have z minus x plus 2y and z plus x minus 2y. This is the answer to this. This, if you expand this is what you get. So can you see something now? This one now, though it looks as if it will work, but it didn't work because there is no relationship between these two. So that is why you need to check where before you start. There is another person may even succeed in looking for alternative way of solving this and still get this. But when you get it right, you will know, because the rule is that anytime you factorize, the two brackets must be what? The same. But we are not having anything in common here. So there is no way we can achieve this. So this is the best approach. That is why, in our last class, we did something like this. That is this bracket here. So the previous classes help you to see, to think far, to know what to do. So another person can consider this and this, bringing now this. So there are many possibilities anyway. I can decide to factor S out here. If I factor S out here, what I have inside that bracket, what can I do with it? If I bring out Y here, I can put this in difference of 2 square. But this bracket will not match with that difference of 2 square. So I can't go further, just like this one. This is what we are to do. So this is the correct answer for this number 4. And that brings us to number 5. So number 5 is even more easy. It's even easier. Number 5 is easier than number 4. If you look at number 5, and if you understood what I just finished teaching you, just from here down, consider from here down, you will see that it's similar to what we just finished solving. Anytime you see two variables, know that this Q and Q has square and R has square, know you can be able to combine the 3. So I can write this number 5 like this. 9p square, bring this minus out. If this minus is outside, what will remain? It will remain Q square minus 6QR plus 9R square. So this one is even easier. Now, we are factorizing this. You bring this one down. 9p square minus, what will I add to give me 6 times to give me plus 9? That is minus 3 minus 3. So that is Q square minus 3QR minus 3QR plus 9R square. Can you see that now? So we have 9p square minus, in this first pair, what is common? Q. Q outside, what will remain? Q minus 3R. In this second pair, what is common? Minus 3R, what will remain? Q minus 3R will remain. So the rule of factorization, again, the two brackets are the same. If I bring out the common bracket, one of them, Q minus 3R, what will remain here? It will remain Q. What will remain here? It will remain 3R. Yet again, you see that 9p square minus this one, since they are the same, means Q minus 3R square. So this is another difference of 2 square. But this time around, remember that this is 9. 9 means 3 square. If I may write it, I can write it as 3p square minus Q minus 3R square. So if you apply difference of 2 square here, you will now have 3p minus Q minus 3R, then bracket 3p plus Q minus 3R. You open the bracket and you get your answer. So we have 3p minus Q plus 3R and 3p plus Q minus 3R. This is the answer you get. So the expansion of this is what gives you this. The expansion of that gives you that one. Okay, let's close this class with this example. Example 6. Make sure you watch the next class. So I've told you, that is where you see more complex ones, more difficult ones. But look at this. It's looking scary. But if you have been following what I'm teaching you, you will have seen what to do. You will know what to do. What do I mean by you will know what to do? Anytime you see AX, YZ, if you see AX, know that you are going to use this with S square and A square to go and locate the one that has A square. This is what I mean. I will start with 4S square minus 12AX. Since in between 9 is AS, the next one I should pick will be the one that has A, which is plus 9A square. That is 1, 2, 3. Now this one, the same thing is applicable, but I have to start with minus Y square, Then put this one at the center, minus 2yz, then minus z square. I only rearrange. Now, if you, let's do one thing first. Before we start, 4a square minus 12as plus 9a square, bring this minus out. So all this one will now be y square plus 2yz plus z square. Now, let's factorize this now. This one. Then we'll factorize this one. To factorize this, two numbers will add to give us 12. And add to give us 12 times to give us 36. So we'll quickly check for the 36 as a product of 8 prime factor. 2 going to 36 is 1 into 16 is 8. 2 go here is 9. 18, then 9. This is 4, and this cannot give us. We have 3. That is 6 and 6 will work. I just check it now. So 6 and 6 will work. So here will be 4s square minus 6ax minus 6ax plus 9a square minus, here, of course, 1 and 1, y square plus xz plus, or yz plus z square. Because this plus this will give you this. This and this will give you this. Now, let's factorize in pairs. In these first two, what is common? 2x is outside. What will remain? It will remain 2s minus what? 3a. In this one, what is common? Minus 3a is outside. It will remain 2s minus 3a. That is for this one. Then minus for this other one. What is common here? Y. What will remain? Y plus z. Here, what is common? Plus z. What will remain? Y plus z. Are you seeing something now? What if you bring out the common bracket? You have what? You have 2x minus 3a. What will remain here? It will remain 2s minus 3a. Then minus y plus z. Then y plus z. So what does that mean? This means that 2s minus 3a square minus y plus z square. So to complete this, use difference of 2 square. That is 2x minus 3a minus y plus z. Then the second bracket, 2s minus 3a plus y plus z. Open the bracket and get your answer. This is 2x minus 3a minus y minus z and 2x minus 3a plus y plus z. That is the answer. But if we choose to arrange the values, this is the answer anyway. But if we choose to rearrange it alphabetically, we can say minus 3a plus 2x minus y minus z times minus 3a plus 2x plus y plus z is all correct. Or you can bring out the minus, which will affect everything here. Bring out the minus, which will affect. But from here, this is correct anyway. This is also correct. It all depends on the option. Or if you stop here, you are correct. If you stop here, you are correct. If you bring out this minus, so that it others with this will change to minus, plus, minus. You bring out this minus, this will change to minus, minus, minus. Minus times minus plus. It's still the same thing. It's still the same answer. So in that case, that one, if I'm to bring out this first minus, this one will now be 3a minus 2x plus y plus z. Times n, if I bring out this first minus, that minus times minus is plus. So you have 3a minus 2x minus y minus z. The 3 is the correct. This is correct. This is correct. Any one you do. You stop here, you are correct. You stop here, you are correct. You stop here, you are correct. But the main important thing is understanding that when you see something like this, if you see A and S together, then go and look for S and look for A. If you see S and Y together, then go and look for Y and look for Z. In our next class, you will see factorizations that are more complex and cumbersome. Raised to the power of 3, raised to the power of 4, raised to the power of 5, even raised to the power of 8. I will show you, so don't miss the next class. And make sure you subscribe to our YouTube channel. Our handle is the same, YouTube, Facebook, Just Academy Mathematics. If you want me to teach you one-on-one, you want to learn maths, any topic at all, send me a message via WhatsApp. The contact that is showing on WhatsApp, send me a message and we'll take it up from there. Thank you. See you in our next class.